3 squared root of 2, does everyone agree? How did I do that so quickly? 45, 45, 90. If I have an isosceles right triangle, I know that that's 45, 45, 90. So I know 1, 1 squared root of 2. See if you can figure out the following trig ratios without a calculator using reference angles and special triangles. This is what we are learning. This is a big thing for the day. If you have no idea, it's okay. So I want to find a cosine of 5 pi over 4. First, I need to find out what the angle 5 pi over 4 looks like. Right? And so where is 5 pi over 4?
Now, cross it to the third quadrant.
It is in the third quadrant. Why is it in the third quadrant?
Because it's past 4 pi over 4.
It's 1 pi over 4 past 4 pi over 4.
Yes.
Do you agree? So it is 225 degrees, 1 pi over 4 past 4 pi over 4. I'm going to find the reference angle for that. And what is the reference angle?
Subtracting.
Okay, and what is it? I will say radians or degrees.
It's pi over 4.
Pi over 4, 45 degrees. Everyone agree?
Yes.
This angle makes a 45-degree angle with the x-axis. So that means the ratio of the sides of those triangles would be 1 line radical 2. The new thing for today is since we are on the coordinate plane, if I am going left 1 and down 1, what kind of values do you get when you go left and down? I know it's weird, we got a negative triangle, we'll take it. So what is the cosine of that angle if the triangle truly is like that way?
Jason and I find this.
So what would I get?
I find Jason. And then you have to multiply this.
If you will, type in the cosine of 5 pi over 4 in your calculator. To do that, what must your calculator be in for radians? Calculator must be radians. Type cosine of 5 pi over 4 in your calculator. And then type negative 1 over 2 in your calculator. See if you did a good job. Type in the cosine of 5 pi over 4. And then see if that's the same as what we just got. So that's how your calculator calculates trig values of non-acute angles. So things like 5 pi over 4, 225 degrees. So this has opened up another set of ACT questions to you. Now you can find things like this. Figured it out that it's not 30 or 45 degrees. Any questions about that one? Now that you know that, try the next one. Are you ready? They'll give you a decimal. I'll give you the radical. I just want to know if it's the same. So then you have to go type radicals over to it and see if you get the same. Your calculator can't give you the square root value. It can give you the equivalent. What's the first thing you're doing? Finding out where 2 pi over 3 is, right? Second quadrant, how do you know? Less than 3 pi over 3, right? And what is 3 pi over 3? That's pi, so it's pi over 3 less than 3 pi over 3. So it's in the second quadrant. What is the reference angle? -60 degrees. Now, if you did that in radians, you get pi over 3. Same thing, right? So pi over 3 or 60 degrees is my reference angle. How did I find that? Subtract it from 3 pi over 3. And 3 pi over pi over 4 has a reference angle that's a 45. You might want to watch that. I will say it again. If your angle is a reduced pi over 3, now it doesn't need to be reduced because otherwise it would be pi over 6, but if your angle is a pi over 3 angle, then you have a 60-degree angle. If your angle is a pi over 6, you have a 30-degree angle. And if your angle is over 4, you have a 45-degree angle. So then essentially all you need to figure out is the signs, what quadrant you're in. So that's good. Save you some time. I spend probably about 2 or 3 more days on this than most trick teachers do. Most trick teachers just tell you the answers and have you memorize them. I found that doesn't last very long, and you can't remember it once you get to calculus. But if you can recreate it, you can. So we spend a lot of time on this, developing where it comes from, so that you can recreate it. So this is a 60-degree reference angle. So I can draw some ratios. It doesn't have to be, it can be any 30, 60, 90 triangle. The easiest one is 1, 2, radical 3. How did I know where each piece went?
Based on the
One's across from the 30, radical 3 is across from the 60, and 2 is the hypotenuse. Are there any negatives?
Yes.
Which one?
Yes.
Why?
Because that's a left.
To the left. Left or down gives you negatives. Why is the radical 3 not negative? Alright, and so I want the tangent, which is opposite over adjacent. So radical 3 over negative 1. Or negative radical 3. So without a calculator, we just found the tangent of 2 pi over 3. We can find the sine, cosine, tangent, secant, cosecant, cotangent of any special right triangle in any quadrant. And so if they're a 45, a 30, or a 60 reference angle, you now can find sine, cosine, and tangent of any of those. This is another type question that shows up on your homework tonight. It says find the value of 6 trig functions of theta if the given point lies on the terminal side of the angle theta in standard position. You almost did this on the bell here. Almost. So let's break that down. It says 6 trig functions on sine, cosine, tangent, secant, cosecant, cotangent of theta, where that point lies on the terminal side of the angle in standard position. What is the terminal side of the angle? Remember from our first day on angles, we start on the positive x-axis and go around. Where we land is the terminal side. The end, like the terminal is the ending place. So 1, negative 8. So I have this angle. Where do I make my reference angle?
To the x-axis.
Oh, it's the x-axis. This side is 1. This side is negative 8, which makes sense. If I were to find sine, cosine, tangent, secant, cosecant, cotangent, what do I need? The hypotenuse. This is the angle that I've got. That's my reference angle anyway. The hypotenuse, I'm going to do 64 plus 1, which is 65. So square root of 65. Everyone know what I just did there? Pythagorean theorem. So a squared plus b squared. So square root of 65 is my hypotenuse. Let me draw that circle out here a little bigger. So now finding sine, cosine, tangent, secant, cosecant, cotangent is just a matter of writing opposite over hypotenuse. The sine of theta is opposite over hypotenuse. I say that? It keeps you from having to rationalize twice. So just use the square root of 65 over negative 8. Does that make sense? I don't need to do the rest. I will. I will. Over 1 on that one. And then tangent. Tangent's easy on this one because it doesn't have any radicals. Negative 8 and cotangent. Any questions about those? Opposite. Okay, so here's what you just learned. We can put a triangle on a coordinate plane. Sine of the angle is the y value of that point. So the point on the coordinate plane that goes around if you're looking at the angle. Over the r value. R is the new letter, but it's just a hypotenuse. So sine is y over r. And you're right. The reason they use r is for radius of the circle that they're creating there. So sine of theta would be the y value of the point over r. Cosine of the angle would be the x value over r, and tangent would be the y over the x. Any questions about that? So that's what we just learned. You need to know it if you know it without writing it down. I'm not going to take your notes up, so.
You folder checked last year?
I'm sure it is.
Yeah, folder checks. Those are always fun.
Yeah, y'all are grown ups.
I always got like one thing wrong, so.
Miss King, I need to see Jake Jager.
However, they're getting loud. Especially if you're getting out. Okay. Any questions so far? So I told you we were going to be looking at finding trig values of special right triangles. So this is finding exact values. Exact, you hear that word? What does that mean? No.
You have to find the front.
No calculator.
What?
That means don't use your calculator. So anytime you use your calculator, it rounds it, right? And rounding creates error. And if you don't want errors, you have to leave things in exact form. So that's where you do this. Now, every year I have a few people say, that's silly, why would you? The calculator is exact. Well, say you're a tenth or 100th off. Maybe that doesn't mean anything. Maybe you're trying to put a rocket on the moon and you're a tenth of a mile off. It's kind of a big deal, right? So it does matter if your rounding is off.
Try it.
Yeah.
I'll get it.
You lost that grocery
So rounding error is a problem for some things.
This calculator just straight from there.
Have y'all ever heard of that guy who made billions of dollars by stealing a penny off of every sale from his company? I don't remember who it was or what it happened.
That's like awesome.
And so no one ever noticed because it was just us. Yeah,
It's funny. It's
it took a long time.
one penny.
Yeah, over
There go you are.
Okay, so 570 was the first thing I need to find out. Subtract 360. First find out where is it. And so if I subtract 360, what do I get?
210.
You really need to calculate. You
No.
we could do it if we had to. 210? Here's 210.
It's a third.
How far away from 180 is 210? 30 degrees? So do we all agree this little reference angle is 30 degrees? Always make the angle with the x-axis. Any questions? So, I can draw a triangle. 5 minus 1.
It's in the negative.
Down
And that one's
Because of back to
and left. Right, down and left in negative directions, so I'll put the curves.
like -2.
The hypotenuse is always positive for now. For now, it's always positive. It doesn't. The only time we'll think of it being a negative is they're really sticky. And then negative flip it. For now.
You said this is the hardest spot of the learning at the beginning.
Yes.
Yesterday.
Oh, sweet. Yeah.
That's what my calculus student said yesterday was the hardest paper in all year. I don't know. You can do it yesterday.
You can get through this.
No one dropped this one. Everyone.
I don't know any AP class.
Okay, so I want to find the side of 170 degrees. That's opposite over. I actually had a student last year who came to me with a drop paper tried to draw. You may have 5 of it.
That sounds exactly something I would do.
We're getting to
I'm lazy. I don't want to do the work. And you decide, oh, maybe I should do the work.
At Christmas, he tried to drop.
See what happens. Well, why?
He had an 89.
Oh, God.
They just happen to draw.
No, he just. He sent me several emails thanking me for not letting him drop.
Wait, Drake has a 5 though. Yay.
No, but AP Cal will next semester. So next semester you'll get a half of a 5-point credit. You get higher credit than free time. So you get an extra.
Like the point until we take the AP exam. Like, then they'll take it into account.
They leave it as a 5 if you don't take the AP exam. They'll take it as a 4. But it's a 5 as long as you.
Why?
In the spring, in the fall, it's the regular.
Basically, it's
Okay, cosine of 570 is what?
maybe no.
And tangent of 570 is. And it is positive because we had the negative over the negative, those cancel. Anna gave me that answer. It is already rationalized. Do I need to explain how she got it? 1 over the square root of 3 is she rationalized. You're good.
Oh, God.
Do I need to do the other ones? Speaking, and you just look at the Okay, what about 135? Let me at least set it up.
Okay, at least it's in the second.
How do you know it's in the second quadrant? Less than 180, bigger than 90, second quadrant. If you get stuck on a radian problem, convert it to degrees. We want to get to where we don't have to do that, but if
The bottom, yeah, that was the one.
The one's going left. So, is that, I heard several of you wanting me to stop. Let's just move on. Is everyone okay with that? You can do signs from here. Okay, let's go next one. What are our options for doing the next one? I can either go the negative direction, or I can add 360 a couple of times. It's up to you how you do that. You can go around. I'll show you this. This would be negative 360, right? So this would be negative 480. So it'd be somewhere here.
Yeah, 150.
So you can do it either way. You can go negative, or you could just add 360 to your plus angle. Either way, those are co-terminal angles, so they'll fall in the same location. So if y'all get 150 degrees.
Oh yeah,
You get 210.
come on, Chris.
Yeah.
You get 210. You get 210.
I am garbage.
Hi, Chris.
You're
Garbage. I'm sorry, that was all recorded.
Chris is
Blackmail! To all the people watching the YouTube, I am garbage. There's like gonna be one view on this video.
2 probably.
I watched
Mackenzie and Jacob probably will. Sorry. Okay.
Jacob.
So negative 510 is in the same location as 210 degrees. What's the reference angle on that? 30. Does everyone agree?
Yes.
So if it's one radical 3 triangle, what's negative?
1.
Square root 3 and
Can we? So it's cosine. Cosine of negative 510 would be negative radical 3 over base over hypotenuse. Okay, so tangent of negative 3 hypotenuse. Okay, write this somewhere down. I'm not done. I do want to do some more examples. But if you are good, 2, 6, 8, and 25 to 33. No.
Hear that, kids back at home.
2 Monday.
So, two.
Here, I'm laughing the problem.
But I don't have written down.
It's been expired to convince me to make it. Start. What? If you feel like you don't.
Oh, just do more examples like this one. Well, I want to do it right.
Hey, so your question, if you are good, you can. If you feel like you need a few more examples, I'm going to do some radian examples. I want to see some radian examples.
33 just
All.
you're welcome, Adelaide.
And I know y'all haven't used the text like in a year, but what do you know about the odds in a math? So you can check those, make sure you're on the right track. What? And so teachers have a set that we can assign to every section and a set that we can assign to every. Okay, guide fire 3. What class? Okay, if you are working, you still have to be fine. If we are in quadrant 1, how do you know?
because it's not less than 90.
It's less than pi over 2, less than 90 degrees, right? And we did learn a trick for saving ourselves some conversion time. Pi over 3 is 60 degrees.
swap out. Or you just try.
How much do you left?
No, when you get 60 degrees.
You have to convert it to a degree.
You have to.
This one is divided by 3.
Yeah. So, what is the sign of 60? So, memorizing that over 3s make 60s and over 6s make 30s and over 4s make 45 will save you some time. So, converting. Any questions so far?
So sine 5 over 3 is equal to sine 3 over 3 over 2.
10 to the pi over 4. Okay. Again, what quadrant are we in if we're just pi over 4? First quadrant, that's less than a half, right? Pi over 4 is less than a half. So we are in the first quadrant, and it is a 45, because over 4s make 45. So what is the tangent of pi over 4?
1. You pi.
Are you in radians? No, hold on. It's sine of pi over 3 is 0.866. But the answer is just radical 3 over 2, not sine 7 3 over 2. So it is the ending side of the angle. So if you're making an angle, this is the terminal side. So the angle starts here and ends here. So, okay, speaking of pi over 6, where is pi over 6? First quadrant, and what kind of angle is it?
30 degrees. 30.
Secant is hypotenuse over adjacent. So it's 2 over radical 3. Okay, any questions about that? Okay, sine and negative sine pi over 6. 7 pi over 6. If you have not been listening, you might want to listen for this one. Because it's a negative radiant angle. Okay. If this were degrees, I probably would add 360 because it's pretty easy to do in degrees. In radians, I actually prefer just going backwards because of the fractions in there. It makes it pretty easy to do that. It is up to you how you decide to do that, but watch this. Okay, if we're going negative, right, so we're going this way. Would you agree this is 6 pi over 6? So 7 pi over 6 would be a pi over 6 angle in that quadrant?
Yes, 30 degrees.
A 30-degree angle. So I think radians are actually a little easier than degrees because the numbers are smaller, more manageable.
Yeah.
Where degrees you had to think negative 5, 10, right? That was kind of a lot to do, but in my opinion, you could do it however. You could also make it positive. If you did, you would get 5 pi over 6.
That's all you do. Just opposite.
Negative radical 3 is the adjacent side because it's going left. And so the sign would be 1/2. Have you noticed that the sign of any 30-degree angle in any quadrant is either positive 1/2 or negative 1/2?
Yeah.
So you see how we could memorize this later and make it pretty efficient. We will do that.